Yo, what's up YouTube? This is Matt Stats and we are back with another video for you guys. And actually we are continuing with matrices. I know everyone here enjoys doing matrices, and so we are continuing with that matrix story. Before I forget, before we continue, take a moment to like and subscribe to the channel. And of course, you can donate via my Cash App, PayPal, and Zelle. They are all in the description down below. And today, I have a quick shout out to one of our subscribers. Guys, I mentioned if you subscribe, put your name so I can mention you in my next video. And today's subscriber is, if I butcher your name, forgive me. I may have pronounced it wrong, but I believe it's Shashank Mewada. Actually, I'm gonna write it down on the video so you guys can actually read it for yourself. His name is Shashank Mewada. And so this is our latest subscriber. Thank you, Shashank, for subscribing to my channel. And anybody else, put your name down in the comment section below or mention it. That way I can actually give you a quick shout out next time I make another video. So guys, without any delay, let's get to the video. So let's talk about matrix. First we're gonna talk about determinant. Or how do we find determinant? Well, it's very simple. If we have a 2 by 2 matrix, all right. If we have a 2 by 2 matrix, this is how you find the determinant. You basically in a 2 by 2 matrix, so determinant what is the first thing first? What is a determinant? It's a number. So every matrix has a determinant. It has a number that when you do certain operation, it gives a number. And to find the determinant, in this case, we have a 2 by 2 matrix. Okay. How do we find this? Let's say we have this right here: -1, 7, 5, and 4. Well, how do we find this determinant? For a 2 by 2 matrix, all you do is you multiply the first diagonal from left to right. This one. Actually, my bad. I should have used something better than that. You multiply the first diagonal. Okay, well, not this one. Yeah, the first diagonal. You multiply the first diagonal. All right. So it will be -1 times 4, and then you subtract the second diagonal. You subtract the second diagonal from the first diagonal. okay, which is minus 5 times 7. And that's it. That's all you do. You multiply the first diagonal from left to right, so negative 1 and 4, and then you subtract the second from that one. So what would that equal to? That would be negative 4 minus negative, or minus 35, because that's a positive, that's negative. So that would be equal to negative 39. And this is the determinant for a 2 by 2 matrix. That's all you have to do. Now, know your terms. When they say find the determinant of a 2 by 2 matrix, you should know that's exactly what you need to do. Second thing we're going to talk about is minor of an element. Now, this one is usually used in a 3 by 3 matrix. So basically, the minor of an element in a 3 by 3 matrix determinant is the 2 by 2 matrix determinant, right? That is obtained by eliminating the row and column that contain that element. That was a lot of wording. I'm gonna just break it down to make it as easy as possible. All they are saying is this: if you have a 3 by 3 matrix as follows, let's say we got alpha, theta, and gamma, and we have 1, 5, 7, ms, t, q. Let's say we have this kind of 3 by 3 matrix. What they are basically saying is this: if you want to find the minor of an element, let's say we're going to find the minor of alpha. The minor of alpha, okay, the minor of alpha is basically, you take, let me use that. The minor of alpha, this one, is basically, you take alpha out, and then you rewrite the determinant, which would be, by doing this, you basically you are crossing out every other element that is on the same row and column of alpha. And that would be, you're crossing out theta and gamma, and you're crossing out 1 and ms. So now what is left? All that is left is this right here. So that would constitute the minor of alpha. So that would be alpha times what? 5, 7, t, q. This is how you find the element of the minor of an element in a 3 by 3 matrix. Now, let's say we were trying to find for theta, it would have been the same thing. The minor of theta would have been what? You would look at theta. This is theta, and you would cross out everything on the line of theta and everything on the column of theta. And what do you have next? All you have left is, let me erase that part real quick. All you have left for theta is what? When you cross that out, you get 1 ms and 7 q. Right? So that would be theta 1 ms 7 q. And that's how you find the minor of theta. And if you were to do gamma, it would have been the same thing. You just cross out all the elements that are on the same row of gamma, and the same column as gamma, and you get what you are looking for, which is 1 ms, 5 and t. That's all you do when you are doing the minor of the element. Let's move on, because before we start doing more exercises, we have to get the terms out. Next, let's talk about cofactors. What is a cofactor? Well, I'm gonna put it that way for you. Cofactor is basically the minor of an element times, I would say, that you multiply by a sign. So cofactor, I'm gonna put it like that. Cofactor is basically the minor of an element, right? The minor of an element. If you remember your set area, your set, that's the sometimes sign for element. It's the minor of element that you actually multiplied by a sign, either positive or negative. So it's the minor of an element that you multiply by a sign, either positive or negative. How does it work? It works as follows. It usually works in a 3x3 matrix. Again, if we take that example right here, well, how would the sign actually work? If I am not mistaken, and you guys could correct me if I'm wrong on that part, but I'm pretty sure it would be something as follows. It would be positive, negative, positive. So when you are doing the cofactor, the first number you're going to use will be a positive times the determinant, and then the second one will be negative times the number times the determinant, and the last one will be positive times the number times the determinant. Now, and then when you go on to the second row, it will be negative, positive, negative, and on the third row it will be positive, negative, positive. So that would be the signs when you're doing a cofactor. Yes, that will be the signs when you're doing a cofactor. This is how you do cofactors. Don't forget that part, guys. Don't forget that part. This is how you would do the signs when you're doing a cofactor. Okay? When you're using cofactors from the determinant. Now, before we move on, let me do a quick example, very quick example, because I want to see. Actually, no, I'm gonna stop it right here. Actually, I'm gonna stop it right here, because in the next video we're gonna, if you watch this video, then you can do the next one, because the next one I was gonna start showing you an example. I'm gonna allude to this video, but I'm gonna do just example. So guys, I hope at least I made it clear and you guys can understand what I actually was doing, so that when you get to the next video, you already have everything ingrained in your mind and you're ready to go to do more exercise. And again, I wanted to thank Shashank for subscribing to this channel. And guys, keep on doing this and support this channel. You can always donate to the Cash App, PayPal, and Zelle. They are all in the description below. And subscribe to the channel and like this video and click that notification bell so you can get more updates when I put more videos out. This is MathStats. I hope to see you guys again. Until then, MathStats out.